This morning, we're launching a month-long series called Modern Medical Miracles. It's all about amazing new medical technologies that could someday save your life. We begin with a closer look at the most common cancer, skin cancer. Now doctors are experimenting with a new tool that could one day take the place of a biopsy. No knife needed at all.
1, 2, 3. And the lower leg. 1, 2, 3.
Digital photography, one of the tools doctors are using today to monitor people at high risk for developing skin cancer. But it's what could be used tomorrow that I recently tried out.
We have a seat right over here. In today's environment, the key is to find the concerning lesion, and when in doubt, we take it out, because the only way to examine it microscopically is by removing it.
But Dr. Alan Halpern and his team at Memorial Sloan Kettering are helping to develop a new microscope that can see the cells of your skin right on your body.
Is there a spot that you're concerned about?
Nothing scaly, nothing red, nothing itchy, nothing changing, but I do have moles. And moles matter because they're highly associated with the deadliest form of skin cancer, melanoma. So we chose a mole on my arm, took some preliminary pictures, and then examined my skin under the microscope.
And here are the individual cells of your mole. We can penetrate very shallow into the skin, in truth, just about a couple of tenths of a millimeter, but we can get very high resolution.
High enough resolution to see whether cells are normal or cancerous. No knives, no needles. Life-saving technology that's skin deep. And Dr. Alan Halpern, Chief of Dermatology at Memorial Sloan Kettering Cancer Center, is here with some more results. Doctor, good to see you. Good morning.
Good morning.
We were looking for melanoma, the most deadly form of skin cancer. We looked at moles on my skin, and it looked pretty good at the outset, but give me a little bit more information about what you found.
Well, the good news is, yes, it was a very normal-looking mole, and we can see it up here in the left upper panel.
This is what it looked like on my skin.
Exactly. And then we looked at it through a dermatoscope, which allows us to see more features within the mole, and again, fortunately, it looked quite normal. But to show what the technology can do, we went ahead and we zoomed in on an area within the mole, the square box, and using this confocal microscope, or sort of video biopsy, and we zoomed in within the mole as well as in the normal skin. If we bring up the normal skin, what we can see is that each one of the little holes in this honeycomb appearance actually represents a single cell. And you don't see a lot of bright, big cells because this is the normal background skin. But if we bring up the mole, what we'll see is these are the cells that make up the mole. And it turns out the pigment in the mole gives us a lot of contrast with this microscope.
And these honeycomb, white, puffy-looking cells, they're healthy.
So these mole cells look healthy. They're all similar in shape and size. And you see how the distribution seems very even, very regular.
Let's give a comparison now. Let's show people at home what it would look like if this were melanoma.
So here's a side-by-side of what your mole looks like, that nice appearance, and this is an example of a melanoma. So both the individual cells, instead of being round and even, now you start seeing these irregular stellate cells with these projections all over. There's also no uniform architecture.
Now, is it this clear-cut in every case? I mean, can you say cancer, not cancer, in every case using this microscope?
Oh, if only it was. This is a technology that we're developing, that we're hoping years from now we'll be able to more consistently distinguish between the melanomas and the benign moles.
And we're talking 5 to 8 to 10 years down the road. So at the moment, the only way to get these same kinds of results is to actually take a piece of the mole and put it under a microscope. So if one day you can arm dermatologists in their office with this device and they can put it right up to their skin, what's this going to mean to cancer patients?
Well, what it's going to mean is, as we hopefully keep working harder and harder at finding early moles or early melanomas, we're doing a lot of biopsies. If we can do this and show that it's benign, we can avoid the excisions completely.
And when it comes to actually removing a cancerous mole, you can look at the cells and find out exactly where the cancerous cells end and the healthy cells start, so you can make a smaller incision.
Exactly. We're trying to, for large moles, especially melanomas that occur on the face, if we can use this to map the border or the boundary, we can avoid taking out normal skin.
Okay, before this is available, let's give people the information they need to know about what they should be looking for on their skin, especially when it comes to a mole.
So, melanoma, as you said, is the deadliest form of skin cancer. It tends to be a dark spot. If you see any dark spots that are irregular, asymmetrical, multiple colors. If they're bigger than about the size of a pencil eraser, those are all warning signs, but the most important warning sign is if you have a mole that's changing color, shape, or size.
And people should scan their own bodies or have a dermatologist scan their bodies and look in places you might not think, between the toes, under your arms, in your scalp, places like that.
Absolutely. Sun exposure is important for skin cancer, and it's important to protect yourself from the sun, but melanoma can happen anywhere, even where the sun doesn't shine.
Dr. Alan Halpert, this was fascinating, and thanks for letting me be the guinea pig, so to speak, on this.
Thank you very much.
And go back and research this. Get this thing to the dermatologist. Thanks very much.